Hello. So we're going to talk about center of mass. So we also showed it as cm. And let's say if you have a mass that's with an object with a mass equal to m, and then you have another object that's also m in its mass, right? So then you know that your center of mass, it's kind of in the middle, right? So this will be r, and that will be r. So this is your center of mass for this system of two masses. Now, if you have a mass, and then you have something that's slightly bigger, let's say this is equal to 2m, then your center of mass will be closer to this side. And this one here, let's say this is equal to a, then this side here will be equal to 2a, right? So this is center of mass of this system, m and 2m. All right, so that's just intuition. Now, if you want to do it more systematically, right? So you want to do it more systematically, you need to have a formula. And the formula says the following: the x for the center of mass is equal to the total mass, right? So let's say you have two masses here. So m1 plus m2. Then you would times m1 times some kind of x1, and I'll show you what x1 means later, and m2 times x2. All right, so then what do I mean? So let's say if I have this, I have x-axis right here, and I put one mass here. Let's call that one m1, and then I'm going to call the m2 somewhere here. Okay, so let's call this one m2. All right, so some mass m2 here, and let's say this is my origin, right? That's my origin. Okay, so then m1 from this origin is called x1 here. So you can select your reference, right? This is reference here. It's chosen to be here. And your x2 will be this one here. Okay? Then if you do that, let's say this x1 is equal to 1, x2 is equal to, say, 3. Okay? Equal to 3. And say m1 is equal to 1 kilogram, and m2 is equal to 2 kilogram. Okay? And 3 meter and 1 meter. And that's calculated XCM, which in this case will be equal to 1 times 1 plus 2 times x2 is equal to 3, and then divided by 1 plus 2. So that's equal to 6, 7, right? So 7. And then divide by 3. And this is in meter, right? In meter. Okay? So then this is 3. So 9 divided by 3. So 7 divided by 3 is somewhere here. So this is your center of mass. And this distance here will be xcm, which is equal to 7 divided by 3. And from here to here, right? Right there. Okay? So from here to here, that's your center of mass. So that's how you use the equation. And so we're going to extend this to a little more general case. So let's say if I have something like this. Let's see. All right, so I put my mass here, m1, and I put the other mass here, m2, and this is my x1, and this is my x2. Okay, and then this is my y1 here, and that's my y2 there. Okay, so now in this case, this is my x and this is my y. In this case, you can find your xcm. It's your total mass, m1 plus m2, and then x1 m1 plus x2 m2. Same thing, your ycm, right? So your cm will be somewhere to say right there. Okay, so sorry, like that. your center of mass, right? And then this will be your XCM, right? And that from here, this here will be your YCM, right? Is equal to Y1 M1 plus Y2 M2, and then divide by M1 plus M2. Okay? So let's extend it even further, right? So let's say if we have M1, M2, M3, or more, right? So in this case, your XCM will be equal to summation of MI, right? And I from 1 equal to that many, okay? And then you have summation of XJ, and then times the MJ, and then J from 1 to say M, right? So, sorry, yeah, so it should also be N, right? Okay? So then you can extend this one out. This one will be x1 m1 plus x2 m2 plus blah, 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 blah. And then this one here will be m1 plus m2 plus blah, 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 right? Then you can find the xcm. You can also do the same thing for the ycm. You can also do the same thing for the zcm if it's needed. Okay, so that's what we have is center of mass and how you find the coordinate for the center of mass. Okay, bye-bye.